Thank you everyone very much for coming to my talk today. Today I'll be presenting the ARC protocol. ARC is a novel Bitcoin layer 2 solution for payments. I'd like to take a quick poll in the audience before. Who has heard of ARC? Just a quick raise of hand. Oh, wow. Full house. Very good. Lightning is the de facto standard for small to medium Bitcoin valued payments. We love that. We think Lightning is excellent. ARC does not plan to replace anything that Lightning is doing already, but rather take that even further. So Lightning does a very good job with transacting on Bitcoin, but liquidity management with Lightning can be a struggle. Existing pain points in Lightning lead users towards custodial Lightning solutions because it's so difficult to manage a Lightning node. ARC gives users self-custody of their Bitcoin with full interoperability with Lightning. This is our design philosophy of ARC, to extend the payment experience of Lightning and alleviate all of the pain points. The ARC server is your gateway to Lightning. ARC uses a client-server model. There is an ARC server, and that takes care of managing channels and liquidity. Using ARC, users can pay on-chain addresses, pay Lightning invoices, pay other ARCs, pay eCash mints, custodians, anything. In Lightning, there exists an issue called the inbound liquidity problem, which means that in order to receive a payment over Lightning, you must first open a Lightning channel and pay to open that up. That means that if somebody wants to use Lightning in a self-custodial way, they have to pay before they can receive their first inbound payment. This is a huge usability problem that needs to be addressed, and ARC solves the inbound liquidity problem. All burdens of liquidity are shifted away from the user onto the ARC server. The ARC server abstracts away the liquidity management from the user. This makes ARC the natural progression of Lightning. ARC is not here to replace what has come before, but rather it extends and improves upon all of the Bitcoin payment infrastructure which has been built so far. In ARC, we use the VTXO model. Is everyone here familiar with UTXOs? Yes. So VTXOs are virtual UTXOs. They behave very similarly to UTXOs, but they exist within the ARC server. When a user transacts, if both users that are transacting, inbound and outbound, are ARC enabled, they transact directly with these VTXOs. In the case that only one user is on the ARC and the other one is just using a regular Lightning wallet, the user can forfeit their VTXO back to the ARC server, spend it, and then an outbound Lightning payment will be made. This gives full interoperability with all Lightning infrastructure that has been built so far. I love this diagram. This diagram was presented recently by Steve Lee of Spiral in BTC++ Berlin just last month. And what it does is it shows a vision for how ARC fits into the Lightning ecosystem and what the future of Lightning payments will look like. It's a bit small on the screen, but you can see all of these yellow dots in the middle. This is the Lightning network as it exists today. And then we have all of these different layer 2s can plug into that. We have Cashew, Spark, which was recently integrated by Wallet of Satoshi. We have Alby, Fedimint, ARC. We have exchanges such as Coinbase. We have existing Lightning service providers, LSPs. We have the Cashew development kit. All of these plug together, and they all interoperate over Lightning. And this is how ARC will be able to communicate with all existing payment infrastructure that has been built. So where's the on-chain footprint? You know, this doesn't all just exist in the ether. This happens on-chain. So there are round transactions which happen intermittently on-chain. These round transactions happen. You can view them in the mempool. They're just like regular Bitcoin transactions, but they have some taproot magic in them. The inputs of these transactions contain all of the Bitcoin that exists within the ARC. And there is a taproot output, which contains information as to who is the correct owner of all of these virtual UTXOs inside of the ARC. This allows users to retain ownership of their funds even inside of the ARC without holding the UTXO directly. The ARC server is not a custodian, and users must intermittently refresh their funds in these rounds. So when a user wants to leave the ARC, exit it, they have two options. They can offboard with participation with the ARC server, or they can perform a unilateral exit. The offboard is a cooperative exit. So the user says, I have my money in ARC, and now I want to bring it back to on-chain. The ARC server cooperates, and the UTXO is returned to the user in their regular Bitcoin wallet. In the situation of the unilateral exit, the ARC server might go offline. It may attempt to act maliciously and restrict access to the user to prevent them from withdrawing their Bitcoin. The user is able to perform a unilateral exit, which means that they can, using all of the information that was in those round transactions, which I just mentioned, they are able to take the money out without permission of the ARC server, ensuring that they always retain self-custody of their funds. So how do we integrate ARC? Any existing wallet or exchange can integrate the second, this is our implementation of ARC, which I'm representing today, with our Bark library, and the wallet will become ARC enabled. We're building a wallet SDK which can be integrated into any existing solution. That will allow users to manage their liquidity through VTXOs, but continue to transact with Lightning, on-chain, and whichever other way. This is a seamless transition into the future of payments. So how does ARC upgrade Lightning? We have, so I've broken down this in a chart here. We have custodial Lightning wallets, and we have running a Lightning node. Both are very good at making fast transactions with instant finality. I would say custodial Lightnings are a lot easier to use, especially for non-technical users. Custodial Lightnings also alleviates the need for users to manage their own liquidity, but they do not own their own funds. ARC solves all of these. It allows users to easily transact with Bitcoin Lightning while always retaining ownership of their own funds. Users are always able to unilaterally exit the system and get back their UTXOs on-chain. You have no worry of a custodial Lightning provider denying you access to your funds or going offline with your money. ARC also makes Lightning more capital efficient. So this is a summary of some of the research that I've been working on in the last year at Second. And we have a scenario here where I modeled large scales of Bitcoin payments. And because in ARC, all of the Lightning channels are abstracted away from the user in the ARC server, this allows for Lightning liquidity to be managed more effectively. And here's a scenario that we've simulated where it is 3 times less liquidity is required in order to do the same amount of payments on ARC rather than with Lightning opening and closing channels and so on. I invite you all to try ARC today. We have our SIGNet up so you can test out ARC in the command line in a test environment, and we'll be coming on mainnet soon. So thank you very much, everyone, for the opportunity to present. And one special bonus announcement, we'll be having Bitcoin Plus in Toronto next summer. So the World Tour Premier Bitcoin Developer Conference Series will be coming locally to Toronto, and we'll make it open and welcoming and accessible for everyone to come and learn about technical Bitcoin. So I really hope to see you all there. You can learn more at the link on screen and talk to me after the presentation. Thank you. Yes. Now to questions from the audience. Go ahead.
Hello, I'm Azad from Bull Bitcoin.
Yes.
And we are doing some research and development about ARC to integrate it in the Bull wallet.
Yes.
Actually, we are working with ARC Lab SDK.
Yes.
And I was wondering if there is some interoperability with your SDK or even your ARC server. Like, can we connect to your ARC server with Arc Labs implementation, for example?
So the way that different ARCs interoperate is through Bitcoin Lightning. It's a little bit different than the different implementations of Lightning. So when you have Core Lightning, LND, now N-Lightning, LDK, all of these follow a very similar spec because they're all communicating with each other through Lightning itself. But when it comes to ARCs, you have different implementations of the ARCs, but the way that they will speak to each other is through Lightning. So this allows Arc Labs to have their own approach. It allows Second to have its own approach. And we will not communicate with VTXOs directly between the ARCs, but they'll be interoperable through Lightning.
Yeah.
Go ahead.
I don't mean about, like, currently we are communicating with Arc Lab servers.
Yes.
Through their own Arc implementation in Rust. And my question is more like, can I connect to your server using their implementation in Rust? Of the Arc protocol?
Like the client, right? So is the Arc Labs client compatible with your server, or is there breaking changes?
No, they are independent connections. So you would use the Arc Labs SDK to communicate with theirs, and you would use the Bark SDK in order to communicate with our Arc.
And it's in Rust, Bark?
It's in Rust, yes.
Well, I have more questions. Great presentation.
Thank you very much.
Good job. Really good job.
Yes.
Okay, so when you do a round transaction, right? The server is paying for it.
Yes.
What's the fee model for a user adding their VTX information to the Taproot output? Like, are they gonna pay, or how is that gonna be deducted? And I have another question, but it's just
So VTXOs have a limited lifespan. So a VTXO might only exist for 1 month. What will happen is that in order to participate into a round, the closer a VTXO is to its expiry point, the lower the cost will be. And the reason why is that when you participate in a round and you hand over Bitcoin to the Arc server must carry the burden of holding onto that liquidity. It wants to minimize that burden. It wants to hold Bitcoin for the least amount of time. So depending on the user's intent, the lifespan of the VTXO, there is different pricing models. And the user has full control over that because it's not a custodian.
right. And so when I'm refreshing the VTXO or when I'm boarding, presumably I'm going to be paying a small fee to the Arc server for that.
Yes, that's correct.
Okay. And is that, like, I don't know, I guess we'll see, but do you guys have an idea of how much that's going to cost?
I look forward to sharing the pricing model with you when we're ready to publish it.
Okay, I have another question. So in the arcade model, when the VTXO expires, it kind of like becomes this like weird Bcash token kind of thing that you can like redeem later. So how does Second handle expired VTXOs? When
a VTXO is expired, a UTXO will be returned to the user.
Oh, so it just offboards.
Yes, the user will offboard and they will receive their funds back in their wallet.
Right.
Yes. And we're looking at, well, the user would pay the transaction fees for that, but we're looking at reducing those liveness requirements with upcoming covenant upgrade soft forks. So there's different additions that we're building internally. There's a really good post on Delving Bitcoin that I can share the link with you where we have Arc, Clark, Hark. These are all different forms of the Arc that we're building out. And some of them depend on things like CTV, template hash, checksig from stack, and they remove a lot of the requirements of a user having to come online in order to refresh their VTXO, and then they would not be stuck with those paying those on-chain fees. But that depends on future updates to Bitcoin. But Arc is ready to go without any additional soft forks immediately.
What are the main criticisms of Arc, and how do you usually address them?
One of the criticisms would be that if so many users are connected to a single Arc, that would mean that there would need to be so many people plugged in to one single Arc. The Arc might need hundreds and hundreds of Bitcoin, and that would be more than any single one could have the burden of. So on the Second blog, you can read some articles that I've done that address this, and we talk about the realistic upper limits of how much Bitcoin is involved. And it's all less Bitcoin than, say, treasury companies have on hand. So if any treasury company wanted to deploy their capital, that would more than fulfill the usage of Lightning that we can see currently on the network.
So I've got a lot of questions about that. So do you know roughly, so if there were to like supply liquidity by giving Bitcoin, what would the return be on it compared to Lightning?
The return comes from the refreshes and the costs that come from onboarding. So to follow up to what Francis asked a bit earlier, where we have different pricing models. So a user can choose how quickly they want to refresh, the trust model that they would like to use, and this affects the fees that the Arc server will charge the user. It's not a flat fee for everyone. Depending on usage, the fees will vary. I'm happy to speak further after the presentation. Thank you everyone very much for your time.